Hello and welcome back to another episode of Math with Zone. Today we are going to be dilating figures, but not around the origin. So buckle up, it's going to be a rough one. Let's get into it. So if the center of dilation is around the origin, things are easy, because then you would just take these coordinates and multiply by 4. And we'd end up with negative 12, negative 16, and so on and so forth. You would just multiply everything by 4. But if the center of dilation is not the origin at 0, 0, in this case it's at 0, negative 5, then we're going to have to do some things that are different. So the first thing that we need to do that is different is plot the center of dilation, which is at 0 down by 5. 1, 2, 3, 4, 5. All right. So that is the center of dilation. I'm going to make it really big. That is where this thing is going to be dilated from, and it's going to get 4 times bigger. And what we're going to do is we're going to kind of count the slope in a way for each and every one of these points. So here, if we were counting the slope, it would just be going straight up by 2 to get to this point. So if I want it to be 4 times bigger, instead of going straight up by 2, I would have to go up by 4 times that amount. So it went up by 2. Instead of going up by 2, I have to go up by 4 times that amount, which means I'm going to have to go up by 8. So I'm going to count up by 8 from the center, not from the point that we, right here. It's going to be from the center up by 8. 1, 2, 3, 4, 5, 6, 7, 8. And it'd be right there. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. All right. And that was point C. So this is going to be C prime at 0. What is it? 1, 2, 3. 1, 2, 3. Yep. 0, 3. And we're going to do that for each and every one of these points, but in a maybe down and over type of technique. So here, if I was going to this point, which is point D for that matter, we went down by 1 and over by 1. Well, instead of going down by 1 and over by 1 to the right by 1, I got to go down by 4, multiply the 1 by 4, and over by 4, multiply that by 4. So we're going to go down by 1, 2, 3, 4, and over by 1, 2, 3, 4. Plot that point and figure out what that coordinate is for D prime, which is going to be 1, 2, 3, 4, and negative 6, 7, 8, 9. Negative 9 for y and 4 for x. A lot of counting. Next one, we went down by 1, 2, and over by 2. So instead of going down by 2 and to the left by 2, I'm going to have to go down by 4 times 2, which is 8, and left by 8 as well. So down by 1, 2, 3, 4, 5, 6, 7, 8 from the center of origin, not center of origin, center of dilation, and to the left by 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. And that would be my new coordinate for, what is that coordinate for? B prime. Nope, E prime. And we would label it as negative 8 and negative a lot. 8, 9, 10, 11, 12, 13. So it's negative 8, negative 13, unless I counted slightly wrong. That's a lot of counting. And then B prime, that's this last one. We went up by 1 and to the left by 3. So instead of going up by 1 and to the left by 3, I'm going to go up by 1 times 4 and left by 12. That's a lot. So left by 12 and up by 4. So I'm going to go start with the left by 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and up by 4. 1, 2, 3, 4. There it would be. And that point is pretty easy to figure out. That point is at negative 12, 0. Negative 12, 0. If you connect these, you get a much bigger shape than you previously had, and it would be centered at that point that we originally plotted at 0, negative 5. One down. Just a few to go. This one's going to be a little less taxing because it's not 4 sides, it's 3 sides. It is going to have a scale factor of 1/3, which means it's going to get smaller, which means we should be happy because it's going to get smaller and therefore not as much counting. And I already plotted the original. So let's plot the center of dilation, which is at 4, -1, 1, 2, 3, 4, down by 1. Now, with this being the center of dilation, we should expect the shape, if it's getting smaller, to go closer to it. If it was getting bigger, to probably go away from it. In this case, it's getting smaller, so I expect this shape to be somewhere around here, getting closer to that center of dilation. So let's count. How much did we go down and over? Notice I'm counting from the point of dilation. Always count from the point of dilation, never from the points on your actual triangle or whatever shape you have. From the center of dilation. From the center of dilation. We went down by 1, 2, 3, and over by 1, 2, 3. Okay, well, if I went down by 3 and to the right by 3, what is 1/3 of 3? Well, that would be 1 and 1 again. So I need to go down by 1 and to the right by 1 instead. So down by 1, to the right by 1 instead. There's my point. Don't lose which one's the center of dilation. That one's this one, center. Next point we're going to plot is going to be, I'm going to pick this one right here. We went down by a lot. We went down by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and to the left by 1, 2, 3. So if I went down by 12 and to the left by 3, what's 1/3 of 12? Well, you just divide 12 by 3, and that would be 4. So I got to go down by 4 and to the left by 1. Okay, well, let's start with the down by 4. 1, 2, 3, 4, and left by 1. There it is. Now look what happened here. This is an important feature. Notice how this line, I drew that side of the triangle, is parallel to that side. This side that we just drew is parallel to the one that was there. That needs to happen. These need to be parallel. Okay? Last point is going to be right here. I went down by quite a bit. I went down by 10, maybe 8. 1, 2, 3. Always count from the center. 1, 2, 3, 4, 5, 6, 7, 8, 9. And to the right by 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 9, right by 9, which means I have to go down by 3 and to the right by 3. So from the center, down by 1, 2, 3, and right by 1, 2, 3. Well, look at this. It's going to actually line up with it. And I made a mistake. Don't put the line through the center right there. It's going to be right there, these 3 points that we have. Okay? So, moving right along. I don't care about these right now. I'm just wanting to keep on trudging. So, if we have these for our next problem, we are going to be using a center of dilation of -2, 7, and a scale factor of 2. So we're going to get bigger, unfortunately. Plot the center of dilation. We're going to go to the left by 2 and up by 1, 2, 3, 4, 5, 6, 7. This one, the center of dilation is in the middle of the shape, so when we dilate it, this shape is going to kind of be around the other one. And I'm going to dilate this short side first. Okay? We went up by 2, left by 2. If the scale factor is 2, instead of going up by 2 and left by 2, we have to double that. So instead of going up 2, left 2, we're going to go up by twice as much, which is up by 1, 2, 3, 4, and left by 1, 2, 3, 4. There it is. Next one, we're going to have to make sure it's parallel, so we're going to recognize that and know that this line is going to be somewhere around here. We went down by 1, 2, 3, 4, and left by 1. So I need to go down by twice as much, which is going to be not down by 4 and left by 1, but down by double that, down by 1, 2, 3, 4, 5, 6, 7, 8, and left by 2. And notice how it is parallel to the original line that we had. Last one, we went up by 1, 2, 3, and over by 1, 2, 3, 4, 5. I need to double check that. We went right by 1, 2, 3, 4, 5. So instead of going up by 3 and over by 5, we need to double that, which is up by 6. 1, 2, 3, 4, 5, 6. And over by double 5, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When I connect the dots, is it parallel to this side? Absolutely. That needs to happen. Is this side parallel to this one? Yes, it is. They're going in the same direction. We have done it correctly. That is a definite thing that you need to be double checking, is that things that we wanted to be parallel are parallel. Something that happens on the FSA, I wish we had started with this one, is dilating a line. Okay, so I took off 2 of the points so we could just dilate a line. And I'm going to plot -1, 8, -1 up by 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to plot 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to be dilating this line segment only. Okay? M and A if you want to label the points. It is going to be centered about the dilation of 3, 4. 1, 2, 3, 1, 2, 3, 4. So this is going to be our center, which I'm going to also kind of highlight with black so we kind of get like a double whammy there. It is going to be getting bigger by a scale factor of 3 over 2, which means it's going to be 1.5 times bigger. All right? So 3 over 2, if you divide it by that, you would get 3 divided by 2 equals 1.5 times bigger. So what I'm going to do is I'm going to count up and over, and I'm going to take that and multiply it by 1.5. So how much do we go up and over? 1, 2, 3, 4. If I want to go 1.5 times 4, well, 4 times 1.5 is 6. So instead of going up by 4, I'm going to go up by 6. 1, 2, 3, 4, 5, 6. And instead of going to the left by 1, 2, 3, 4, I'm also going to go to the left by 6. 1, 2, 3, 4, 5, 6. Look at what happened here. These all line up. That is supposed to happen. The 1, 2, 3, these have to line up. Same thing's going to happen on this side as well. So when you're dilating a line, a special thing happens, and we kind of make a triangle with everything lining up. So let's figure out how far we went up and over for point A. We went up by 1, 2, 3, 4, 5, 6, and over by 1, 2, 3, 4, 5, 6. That's kind of lame. So we went up by 6 and to the right by 6. 6 times 1.5 is equal to 9. So instead of going up 6 and over 6, I have to go up 9 and over 9. Up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and over by 9 is going to give me this point right here. Look at how they line up. These two things line up. This point and this point, those were the points that actually mattered. So this line that I'm drawing, this is the one that actually matters. And a lot of people look at this and are like, well, that doesn't look like 1.5. It's not the distance from here to here that needs to be 1.5. It is the distance of the line segment that we actually drew. How big that line segment actually is 1.5 times what MA used to be. And the slopes dictated it as well when we counted them from the center of dilation, which was 3 over 4. All right, that's going to do it for this episode. Till next time, stay positive, and I will see everybody later. Bye.